Hi everybody, welcome to video number 2, which is probably the Thursday lecture. Hopefully we'll get all of it in this first part of the lecture. We're going to talk today about vowels that are in languages around the world. We know that American English only uses some of the possible vowels that can be produced in world languages. University of California at Los Angeles database has identified 37 vowels that are occurring in languages around the world, and there may be more vowels as more languages are discovered, and as we learn finer grained ways of analyzing vowels that we know about. Most languages select vowels from a system of 3 to 9 vowels in total. And those vowels occur across languages. So the most favorite vowels that are used include the E, which is this I sound, the ah or ah sound. We are actually thinking about this as the ah, as in had, and the oo sound. So those are the 3 of our corner vowels. Remember, this is a little bit different as we have been talking about it. If a language has a lot of vowels in it, and the kind of cutoff is if it has more than 9 vowels, the secondary set of vowels is the second group that isn't used as much. If there is a secondary set of vowels after 9 vowels, usually there are only 5 more, so 14 vowels within the language. It's not a hard and fast rule, but that's a kind of a guideline. So a language with a lot of vowels might have 14 vowels. When that is the case, when there are a primary set that are used most frequently and then a secondary set of vowels, those secondary vowels are usually found on the sides of that vowel quadrilateral that we talked about. And of those secondary vowels, there's kind of a balance between front vowels and back vowels, kind of like we see in English. One interesting thing is that sometimes instead of those vowels that fall on the side of that vowel quadrilateral, sometimes the schwa is preferred in lieu instead of those side vowels. Also, it might be of interest for you to know that when you have somebody who has trouble with production of vowels, whether it be because they have a hearing loss and they don't hear a lot of vowels, or they don't hear a fine distinction between vowels, or if it's because there's a physical issue going on in the lips or the mouth, the schwa is a vowel that is most likely substituted for a vowel target. So let me get rid of myself on this one and go back to the slide. So we have first and second language vowels, and people wonder why it's so hard to acquire a second language, why it is so hard to not sound like you have an accent when you learn a second language. And for example, if you start learning Spanish, I chose that one because we have a lot of Spanish speakers in this class. If Spanish was your first language, you learned 5 vowels. You learned E, A, O, U. Then when you learned English, you had to pick up or learn to distinguish additional vowels. So again, if you learned Spanish, you learned E, A, the A, the O, and the U. Most likely, when you learned English, any vowel that was close to E, and in our case there aren't a lot, would be considered fairly hard or more difficult to learn. So in the case of ooh, the sound might have been a more difficult vowel for you to learn. Because Spanish has this ah, some of the vowels that are close to it, perhaps even might have been a difficult one, or because they're close to the targets that you have in Spanish. So with that in mind, if you now are an English learner and you're trying to learn another language that has vowels that are very close to our English vowels, they would be more difficult for you to learn. Okay, let's go to the next slide. I will not click on these links. I really would like you to, even if you could, stop the video and go to the links. The reason being is if I click the links and let you watch the links through this, I get into copyright issues, but I can link you to these. The overall statement here I want you to think about is the vocal tract is a tube. It's a tube that vibrates. It vibrates because that tube is made of human tissue, and it's pliable and soft, and when air goes through it, the tube vibrates. And there's a funny clip from The Daily Show about tubes, and then there is another clip that is really cool, and it shows a sound source, just a buzzing sound source. So I could take something in my hand, like a little motor that has a bzzz sound on it, and I could put a filter over that motor. So let's just say my hand is here, and it's the sound source. It's going zzz. If I put my other hand over it like this and made a tube, I would change the sound of that zzz. And that's exactly what this video shows you. And it's really cool because what they've done is they've taken like a silicone mold of the throat that sits right above the vocal folds, and what the shape of the mouth and even the lips in some cases. And it's like a silicone mold, and they put that over a vibrating source. So the vibrating source is just this kind of this just blah sound. It doesn't sound like any vowel or anything, but it's like the zzz. Then they overlap that filter onto it, and it sounds like oh or ah or ooh. I think it's oh and ooh, because yeah, at one point you can even see the outline of the lips. This is to demonstrate what we call the source filters theory. In this theory, your voice, your vocal folds are the source of the sound. If we had no head above here, and the vocal folds were just vibrating, it would only be this very bland, unformed buzz. What happens is that the sound made by those vibrating vocal folds is then shaped by the length of your voice, the length of your throat, your vocal tract, your lips, your nose, your jaw, just like we were talking about last Thursday. And that sound is then radiated out of your lips. And so it is actually called radiated acoustic energy. I really encourage you to click on these links, this one and this one, and you'll see some pretty nice examples of the source, which is your vocal folds, and the filter, which is the mouth. That brings us to this target of resonance, this term of resonance. Each shape of the vocal tract that we make with our mouth has a particular shape, and there is a resonance or a part, like a sweet spot, that vibrates. and makes vowels sound differently. So again, if I'm just making a sound with my voice and my mouth is just open, nothing's going on with my tongue, lips, or jaw, and it's just an open sound, I get ah. If I shape it and I put my lips out, I get ah. So the way my particular tissues in my mouth and the way my tongue is sitting in there shapes that vibration, and we get these different resonance frequencies. And again, I've got a couple of videos that I really want you to watch. In these resonances, certain frequencies become enhanced or almost amplified, or they are amplified. And these frequencies that are amplified are called formants. And what these formants are basically bands of energy that are related to the shape and the properties and the filtering. And they modify the sounds that come out of our vocal tract. And again, there's a beautiful video on this link that you can't see really well here, but it's on your slide. Please do link to that. Also, as one of your homework pieces, this will be again part of the homework that you'll see. I really want you to download use this link and download onto a computer that you use this application, and it's called Praat. It was developed in Belgium, I believe, and it allows you to make recordings and analyze those recordings on your computer. And we are going to have several labs that work with that. In fact, Praat allows you to actually see what we call a spectrogram. And let me flip to the next slide and I'll show you the things that are identified on a spectrogram. Each one of these pictures is what we call a spectrogram. And you see these bars on the spectrogram. If we went across this line, this is called an axis, an x-axis, because it's going in the crosswise. This would be time. So if I set a recording right now, if I hit record, across time, I might say a sound. Then a few seconds later, I might say e, oo, a, and such. And in fact, what these drawings are, or what these spectrograms are the vowel e, I, a, and a. Interesting about a, remember how we said that diphthongs are two sounds? A, you can actually see this sliding here on this picture. And so the x-axis is time, and going up is frequency. And so this first dark bar here, and all across here is a very, very dark band. That's a band of energy. That's called the formant, the fundamental frequency, and it's formant 0. So it's the fundamental. Then the yellow line I've marked is the first formant. This is the second formant. This is the third formant. And so you can see for the vowel I, the first formant, if we measured it, it would correspond to roughly the pitch of the person's voice recording. And if it was a man, it might be maybe 130 hertz. If it's a woman, maybe 175 or so. So the first formant is here, or the fundamental frequency, formant 0, is here, then the first formant, and second, third, and so on. And you can see how these yellow lines, if you go across a line, these yellow lines are actually gradually getting higher and higher. I'm going to stop there and We will continue with video